Hey guys, in last video we have generated an object file from the assembly source file by using guess. Object file contains machine code, data, and other information like a header, debugging information, symbol tables, etc. But unfortunately, an object file is not executable. Our program only has one assembly code file, but most programs have more than one source files. Then, during the assembly stage, more than one object file will be generated. These object files have to be linked to generate an executable file. The program that can do this job is called a linker. The linker we are going to use in this course is GNU linker LD. Okay, before we use the linker, we need to make sure the current working dictionary is the exercise. Then we input the linker LD. We tell the linker that we are going to link the first .oo and the output file is first. And another two option is -t text equals 0x7c00 and the output format is binary. We see what happens, and we can see from the folder the first, that's the runnable or the executable file has been created. For the second option, the output format equals binary is easier to understand. But for the first one, the -t text equals 0x7c00. It is to tell the linker that we are going to put the text section or the code section to the absolute address 0x7c00 in memory. But why the address number is 7c00? Before we explain why the memory address is 0x7c00, we have a quick look at the startup process of a computer, which is also called booting process. Step 1, power on. This step is applying power to the machine. Then the CPU executes some startup code in ROM, or read-only memory, which is located on the motherboard. The read-only memory is a type of non-volatile memory, sometimes also called firmware. The feature of read-only memory is it will not lose the data even you power the computer. Step 2 is called the post or power-on self-test. This test checks all connected hardware to make sure it is all functioning properly. After post has completed, the booting process searches the boot device list for a device which is bootable. Step 3, loading the MBR. Once a bootable device is found, the booting process begins loading the first 512 bytes, which is also a sector from the boot device. This 512 bytes is loaded into RAM and the instructions starts getting executed by CPU. RAM here is short for random access memory. A random access memory allows data items to be read or written in almost the same amount of time, irrespective of the physical location of data inside the memory. We have mentioned that the booting process reads the first 512 bytes from the device into the memory. The machine code like these instructions plus the code for the definitions of the rules for communications between the CPU and the other devices attached to the computer through the motherboard is called the BIOS, or the Basic Input-Output System. A formal definition of BIOS, it is used to perform hardware initialization during the booting process and to provide runtime services for operating systems and programs. Where is the BIOS? It is located in ROM on the motherboard. We have learned that at the end of the booting process, the BIOS reads 512 bytes, which is a sector from the external device, usually a hard disk or floppy, and put these 512 bytes to the memory. The question for us now is, which memory address does the BIOS put the first 512 bytes to? The answer is 0x7c00. Each of the box stores a bit. Each line of these boxes stores a byte. Makes sense, right? We have already learned that there are 8 bits in each byte. We also can see the minimum addressable unit is a byte. So the very bottom line, that's the memory address 0, and then address byte 1, then byte 2, and so on. By now, we understand why the option for the linker is -t text equals 0x7c00. Strictly to say, this whole process is correct for the legacy BIOS, which means there is something like a non-legacy BIOS exists. Actually, there is a successor of the legacy BIOS called UEFI, which is short for Unified Extendable Firmware Interface. But in this course, we only discuss the legacy BIOS. Now we go back to Ubuntu. We see the first program, which is exactly 512 bytes, and this is created by the GNU linker using the first.o as the input. We are going to put these 512 bytes to some device like a hard disk or a floppy. Then we run the machine to let the BIOS read these 512 bytes from the device, I mean the hard disk or the floppy, and to let the CPU execute this machine code. We will see how to do this in the next video. Hey guys, welcome back. In last video, the machine code file first was created by using GNU linker LD. In this video, we are going to see how to run it. We do not really want to burn this file to a CD or DVD ROM and then insert this to a DVD drive of the computer, do we? Not at all. We are going to install a PC emulator, Bochs. With this emulator, we are going to see how to let the Bochs to load the first program and run it. Now, the problem for us is to install Bochs. Firstly, we go to the homepage, bochs.sourceforge.net. Then we click the download current on the left side. Then we drag to the bottom to see there is a Bochs binary and source releases section. We click into this one. Click the 2.6.9, that's the latest version. Unfortunately, we don't have a deb package for Ubuntu, so we have to try the source file. We need to download this source file, the bottom one, and then try to compile it and install it. We will see whether we can do that. Once we have downloaded the source files, we double click to unzip it, and once we have finished, we go to the folder to see what we can find. Then the task for us is how to compile these source files and to install the program. We go back to the website to see how to compile source files on Linux and install it. We try this one and this one. Finally, on this website, I got these classical steps. Firstly, configure, then compile, and lastly, install to see whether we can do this. Make sure we are under the Bochs -2.6.9 folder. We input the config. Now the configuration has been finished. We try the second step. We can't do that as it says no tag is specified and no makefile found. And we see there is an error set X Windows GUI was selected, but X window library was not found. Probably we need to install something for the X Windows library. We go back to the browser to input how to install Windows X library on Ubuntu. I got this on this website. Let's try whether it works. Then simply do apt-get install library x11-password. Do you want to continue? Yes, we have finished. Well, let's try the configure again. I don't think I see a warning this time, so let's try Mac. We got another fatal error. It says the x1111 extensions xranger.h something, no such a file or dictionary. Well, we will find you back how to install on Ubuntu. And I got this on this website. We go back to terminal to try whether it works. So Quint open. Okay. I suppose we need the super user to achieve this. Yes. Now we come back again. So we need to reconfigure again. The reconfiguration has finished, so we try to make it again. We'll do the last step, sudo install make install, I suppose. Make install. Finally, I hope we have installed. Great, it looks like we have installed. The Bochs is installed. Now we need to check whether the installation is good. We go back to the Bochs website. On the left side, we see there is a disk images link. We click into it. We can download some pre-installed package. So we choose this one, the Pragma Linux, and save file. Once we have downloaded, we unzip this Pragma Linux onto the desktop. And here it is. We click into it, and we can see in the middle there is a file called Bochs HRS. We open it to see. This file is the configuration. We can see fifth line. It says floppy A, so 1-44. That's the size of the floppy equals to a.image, and then the boot column I, which means it will boot from the a.image, and the emulator will take a.image as its floppy, as its bootable device. We right-click in this folder, open the terminal, and then we key in Bochs in, press return to see what happens. Now we can see a list pumps out. Please choose one. Number 6 default is begin simulation, so we press enter. And you can see a window pop up. That's the Bochs x86 emulator. Now it is running, and very quickly it prompts us to key in the password, login password. We have installed Bochs. Great. By now, we make sure that we have the Bochs emulator installed, and also we tested it. Now we need to test our program whether it can be run on the emulator. We open this Pragma Linux folder. We copy everything but the a.image file. So copy and then close. We open the exercise folder, paste everything here, and then we open this configuration file. Change this a.image to first, and close and save. Then we to run it. Open a terminal and input Bochs. Press enter. Then you can see in the middle of the screen there is a line says my first assembly program. That's what we were planning to print on the screen. Don't worry about the other characters for now, and we will explain how our program can do this in the following videos.